Okay, the title of my presentation today is Earth, Fire and Water, and what I hope to do is firstly give you a little bit of background on myself and then illustrate some areas of research that we have going on at the University of Melbourne. So firstly, who am I? I did a PhD in Queensland on post-mining rehabilitation of coal mines, so I'm a kind of soils and water guy. I then worked in consulting for a while before joining the state government forest research group in Victoria, and then moving in 2003 to the University of Melbourne, where I've been associated with the Integrated Forest Ecosystem Research Program, which is a long-term collaboration between the University of Melbourne and DALP in the area of forest research. My work is sort of sits at the nexus of fire and hydrology, so the ways in which fire impact on hydrology, and in turn the way in which hydrology impacts on fire. And the reason my focus is there is that our forests are, the dominant source of water for cities and towns in Victoria, and the forests are also subject to these very large scale and strong disturbances associated with fire. And therefore they're really important for the Victorian community. So firstly, looking at the ways in which fire can impact on hydrology. So fire affects the soil and affects the amount of runoff from the soil, particularly in the short term, so we can get flash flooding as shown in the far left, top left here. This also accentuates soil erosion, so we get impacts on water quality and reservoir water quality. But in Victoria in particular, we're subject to this very intense erosion process called debris flows or post-fire debris flows. And these are really high magnitude events that shift boulders the size of cars, and so they can have a big impact on infrastructure, such as roads, buildings, but also have result in the loss of life in some cases. And there's an extreme example of this in the bottom left from California in 2018. This debris flow here, which came down out of those burnt mountains in the background and impacted on this community, killing more than 25 people and destroying hundreds of homes. And these debris flows after fire can occur even in low intensity fire. So the photo on the bottom right there is of a home up near Myrtleford from 2015 below a planned burn where a debris flow was triggered. So what our research attempts to do is kind of work out where these things are happening. So we have all sorts of experiments going on at a range of different scales to try and determine where they happen, why they occur, how big these kind of impacts are likely to be, and also how likely, so how much should we be worried about these, some of these kind of post-fire hydrologic impacts. And our trajectory of research over the years kind of patches together the pieces in this puzzle, and ultimately aims to come up with sort of risk tools and hydrologic models that can be used by land management agencies, including DALP. And these photos here show an example of the bushfire RATs, the rapid risk assessment teams, using our hydrofire model, which allows them to predict where the location and magnitude of likely debris flows after bushfire. And there's an interesting article there by the National Public Radio in the US, came out and did a story on this integration of academia and agencies earlier in the year when we had the big bushfires. The next couple of slides are looking back the other way, so the impact of hydrology on fire, and probably the most obvious example of this is in landscape drying. So as we have less rainfall and increasing temperature, this will lead to a drying of the fuels, and it's no coincidence that last year was one of our driest on records, and we had one of our biggest fire years on record in southeastern Australia. So just want to draw your attention to that graph on the left there, the relationship between fuel moisture content on the x-axis and ignition success. And the key point there is that the relationship between the moisture content or the dryness of the landscape and kind of fire activity, in this case ignition success, is really non-linear. And these are the things we really have to be watching out for under climate change, these kind of threshold processes where you shift the system just a little bit and it can go through this step change in activity. So our work in the sort of landscape drying and fuel moisture space focuses around trying to understand how fuel moisture changes both in space and time, so the rates and controls and the kinds of models we need, and how this varies along a sort of a gradient of different forest types. So lots of microclimate studies underneath forest canopies, trying to work out how both the climate but also the microclimate in the forest itself influences landscape drying. And one of the examples of this work that's been really, really positive is our collaboration with DELP using these what are called fuel sticks, which are real-time measurement of fuel in the forest, fuel moisture in the forest. And there's been a network of 30 of these established across the state. And we've sort of helped in the development and calibration of these. And one of our challenges now is to kind of fill the gaps between those points. So these very high resolution fuel moisture information at these 30 points, and how do we model between these points using the properties of the landscape so that we can get a very high resolution in space and time model of fuel moisture to particularly help with those kind of practices like prescribed burning, where high levels of detail in the fuel moisture patterns can be really useful for the planners of those events. And lastly, I just want to share a couple of examples of our work, which I guess is a little bit more ambitious in trying to look at feedbacks between hydrology and fire and hydrology. And the first example of that is based on some work we're doing out near Powelltown, and it's built around the idea of, okay, so imagine we have a drying, lower rainfall, higher temperature climate in Victoria. So this can lead to more frequent fire, presumably will lead to more frequent fire, which in turn might lead to species change, as we have different species of trees that are very sensitive to fire frequency. And so what we're looking at is, okay, once that species changes, does that then feed back on the hydrology? So do those different forests, say for example, produce different levels of stream flow, or do they have a different level of shading of the fuels in the understory that determine how available they are for fire? So we may have the scenario where we have a drying climate, which leads to more fire, which in turn changes the forest and makes them more available to burn. So that's one example of this kind of fire hydrology feedbacks that we're investigating. Another example is probably our most ambitious work, is looking at that same kind of problem but at a longer time scale. So when we look around, we see patterns of soil properties and vegetation and fire regimes that seem to be sort of coupled. And what we think is going on is that those areas that are suffering these very high erosion rates after fire, in the long term, they're actually developing shallower soils, and in turn, they're supporting more open vegetation with open canopies, which has drier fuels and a higher fire frequency. So we're kind of interested in how all these things kind of evolve together, and the reason for that is that we use this kind of knowledge to help understand how, as our landscape is drying, how the forests and the fire regimes are going to respond. And lastly, I just wanted to point out that although we're heavily focused on finding the answers to these researcher questions and turning them into information that can be used to guide both policy and management, at a university we're also about research training. So I put together a list of all the people that have been involved over the last 15 years in our projects around this topic area. And I guess what this just helps to reinforce is that we're not just about finding answers, but we're really preparing the next generation of fire and forest and hydrology researchers and land managers through this research program. And with that, I'd just like to finish up. Thank you.